In this video, let's talk about annotations. Now, annotation simply means a supplement to the compiler or to the runtime, or we also call it as a metadata. So basically what happens, when you write a code, sometimes you want to interact with a compiler by saying something. Of course, it will not change the way your code will work. It's just that we want to supply some extra information to the compiler or to the runtime. How do we do that? So let's say we will go for a normal class here. So let's say we have a class A and then we got a class B. So basically I'm trying to go for method overriding here. So of course we have to extend a class and then this will have a method which is show. And then in this show, I'm printing, let's say in a show. And the same thing I can do in B as well. The only thing is we have to change it here. Now, what we are doing here is we are overriding the show method of A with the show method of B. And then we have seen this before, right? Okay, let's create the object of B just to understand this. So I will say B obj equal to new B. And then I can call obj.show and we all know what will be the output. So if I compile this code and run, you can see it says in B show. Perfect. Now, let's say I change this method name. Okay, not show, but something else. I will say show the data which belongs to this class. Okay, so normally in Java, we give a meaningful name to a method, right? And sometimes your method name can be big. And yes, okay, I know this is exaggerated, but sometimes you do have a big method names with 2 or 3 words or 4 words. And then of course, if you want to override this particular method, we have to type the same thing here. So I will say the data which belongs to this class. Okay. So again, I'm just trying to override the method of A class with the method of B class, right? And then of course we have to call this now. So I will just try to get it from the suggestion. Okay, so if you can see, I'm just trying to call this method and what do you think? What will be the output? Of course, we have overridden the method, so it should call in B show, right? So if I compile this code and if I run this code, oh, it is printing in A show. Now we were expecting in B show. In fact, I wanted in B show, but we got in A show. Now this type of problems in programming is called bugs. Okay, bugs are simply logical problems where you are expecting something else and you got something else. Example, you want to say 2 plus 2 and the output is 4, but you got 5. That is logical problem. It's not a compile time issue. It's not a runtime issue. It's the logic which you have written is wrong. And one of the most difficult problem to solve is logical problems. We always say in programming that, you spend less time in coding and more time in debugging. That's what is happening here. So of course you have only 2 classes here and it is easy to debug. But if you have a lot of classes, it will be very difficult. Now, how will you debug? Of course, we are trying to call the method of B class, but we got the method of A class, right? How will you solve this problem? So let's try to understand the method name. On purpose, I changed the method names, okay? I know it might be visible for a few people. You can see in belongs here, we have S. In this method, I don't have it. And sometimes you can miss it, right? And then when I'm calling it, I'm passing S. On purpose, I was calling the method of A class. This type of problems can arise when you write a code. So what you do is, you can show your intention to the compiler and compiler will help you here. Of course, right, whenever you make a mistake, compiler gives you error. And looking at the error, we can easily understand, hey, I did something wrong and let's go back and solve this. So what if you can ask your compiler, hey compiler, you know what I'm doing here? I'm trying to override the method here of class A. And if it is not happening, let me know. So you can show your intention and you can show the intention with the help of annotation. There are a lot of inbuilt annotations available in Java. One of them is override. So you can simply use @ here and you can say override. Now you are saying by doing this to your compiler, hey, I'm trying to override the method. And your compiler says, you know what? There is no method called show the data which belongs to this class in the A class. And then you will know, oh, I made a mistake. And then you can solve this problem just by putting S. Of course, you can compare these 2 methods and you can say, I got the problem. So of course, you have to solve the problem. So compiler is helping you by showing the problem, right? At least you got some help. And solving the problem at compile time is much better than solving the problem at runtime or when you deploy the application to the users. And then users will give you a prompt, hey, you made a mistake. So let's avoid that embarrassment and let's solve the problem at compile time. So at override is one of the way you can do that. And now if you try to compile and run, you will get in B show. Now, apart from this override, we have different annotations as well, which we normally use. In terms of core Java, we don't use most of the annotations. Of course, you can create your own annotations, but in general, we don't use much. Now, once you start working with the frameworks, example, when you talk about Hibernate framework or Spring framework, at that point, it is mostly driven by the annotations. Now, there are some annotations which works on the methods. There are some annotations which works on variables. There are some annotations which works on class level. So example, there might be some annotation which you will be using on class level. Example, if I say deprecated. Now, this is one of the annotation we have. Now, what we are saying that we have this class A. Deprecated simply means you can use it, but don't use it. It is deprecated. Soon it will be removed from the Java language, or there is a better alternative for this. So you can mark your class as deprecated so that if someone try to use your class, they will get to know that this class is deprecated. Now, apart from this, you can also use, okay, these are all class level annotations. In fact, we are going to see one more when we start with interfaces. Okay, so if I try to use something on the method level, let's see what we have. So we have save varargs for the variable arguments. We have suppress warning if you want to hide the warnings. Once we start with Hibernate framework, we'll also see transient. Functional interface we are going to see in the interface concept. Yeah. In fact, when you create your own annotations, we can also set the retention. So example, let's say whenever you use an annotation, till what level you want to set it. Do you want to set for compiler level? That simply means if you set a retention for compiler, it means once the code is compiled, the annotation will not make any sense after that. But if you say annotation is applicable for runtime as well, so after compiling as well, when the code is running, at that point also the annotation will be applicable. So we have different options there. And of course, this will make much more sense once we start working with frameworks. So yeah, that's about annotations. And so we have different annotations. And remember when we were doing method overriding, and if you ask, example, let's say if I remove this part, and if I ask my IDE to generate an override method, so I can just go back here and say override, I want to override this particular method. By default, it will give you at override. Okay, so that's you have to remember. So yeah, that's it from this video where we talked about annotations.